Hey guys, I'm Sue from Group 2. I'm going to explain Extreme Value Theorem and Mean Value Theorem. Extreme Value Theorem explains if f is continuous on the closed interval AB, then fx has both absolute max and an absolute min on AB. And Mean Value Theorem is if x is continuous on the closed interval AB and has a derivative on the open interval AB, Mean Value Theorem applies. And mean value theorem says f derivative of c equals to fb minus fa over b minus a.
Hey guys, Trip here, and I'm going to be explaining to you how to determine concavity. Let f be differentiable on an open interval I. The graph of f is concave upward on I if f prime is increasing on the interval, and concave downward on I if f prime is decreasing on the interval. Right here, on f of x, concave downward right here, and concave upward right here. And on the derivative graph, all values over here are decreasing, so it's concave downwards. All values over here are increasing, so it's concave upwards. To find the concavity of a function, you set the second derivative, f double prime of x, equal to 0, and find where the graph changes from positive to negative using a number line. Take the function f of x equals x to the fourth minus 4x cubed. First derivative is 4x cubed minus 12x squared. Second derivative is 12x squared minus 24x. Factor out 12x, set them both equal to 0. You get 0 and 2. Use a number line, using 0 and 2 as your asymptotes. For values less than 0, you plug into the original equation, and you get a positive value. So from negative infinity to 0, the graph is concave upwards because it is increasing. From values from 0 to 2, plug into the original function, you get a negative value, which means from 0 to 2, the graph is concave down. And from 2 to infinity, you plug in values greater than 2 into the original function, and you get a positive value. So the graph from 2 to infinity is concave upwards. To determine the concavity of a parametric equation at a specific point, you first solve for t using the given point, find the second derivative, and plug in the given value for t.
Hey guys, this is Trevor from Group 2. I'm going to be talking about the Extreme Value Theorem and Mean Value Theorem, and also optimization. The Extreme Value Theorem pretty much states that on the closed interval from a to b, there are extrema. And the Mean Value Theorem, which is this, pretty much states that the derivative of f of c equals f of b minus f of a over b of a. And this relates to optimization because in optimization you're trying to find the maximum and minimum of a given function and to find the answer. So we're going to be talking about optimization, and the problem is a soap company has a container with a square base, and they want to find out the minimum amount of material needed to contain 100 centimeters cubed of soap. So the formula for volume is volume equals length times width times height. And since it's a square base, the length and the width are the same. And so we're going to say that both of them equal x. And so plugging into the volume equation, 100 equals x squared h. And we are solving for h, so we can plug it into the surface area equation over here. So h equals 100 over x squared. Now, to get the surface area equation, pretty much you're trying to get the area of all the sides and then add them all. So add them all up. So there's 2 x squareds and 4 x h's. So we're going to take the h equation here, and we're going to plug it in so we can get all x's. So we get surface area equals 2x squared plus 4 times 100 over x squared times x. And that x cancels out the x squared. So you get s equals 2x squared plus, or we're going to go ahead and skip steps and multiply, equals 400 over x. And 400 over x equals 400 x to the negative 1. So to write it out completely, s equals 2x squared plus 400 x to the negative 1. Now, we're going to do the derivative of it. So we get s, the derivative of the surface area, equals 4x plus, or not plus, minus 400 x to the negative 2. And that equals, derivative of surface area equals 4x minus 400 over x squared. Now, we want to find out x, so we will send the 4x to the other side. So we get 4x equals 400 over x squared. And so we will just take the x squared over here and multiply. So we get 4x cubed equals 400. And we're going to divide by 4. So we get x cubed equals 100. So to get rid of the cube, we're going to do the cubed root of 100. So x equals cubed root of 100, which equals 4.64. And so what we want is we want to find out the height now that we know both the length and the width. So h equals 100 over 4.64 squared, and which is h equals 100, let's fix that, over 21.54, and h equals 4.64, which is the same. So we know that all of them equal the same, and so you get 4.64 centimeters as your answer.
Hey guys, this is Xuan, and I'm here to talk to you guys about curve sketching. Curve sketching is basically talking about the relationships between the graphs of a function and its derivatives. So I drew for you an example. The orange graph is the original function 1/3 x cubed minus x. Its first derivative is colored green, and it's the function x squared minus 1. And its second derivative is colored pink, and it's the function 2x. So I'm first going to talk to you guys about the relationship between the first derivative and the original function. So one of the first things you may need to know is that when f prime of x is greater than 0 on an interval, the function f of x is increasing on that same interval, and vice versa. When f prime of x is less than 0, the function f of x is decreasing on that same interval. So you're looking at the green graph, and you can tell that x is greater than 0 or above the x-axis when x is less than -1 or x is greater than 1. Therefore, the graph of f of x is increasing when on the interval x is less than -1 or x is greater than 1. And you can also tell that between -1 and 1 is below the x-axis or less than 0. Therefore, the graph of f of x is decreasing at interval -1 is less than x is less than 1. The second thing you need to know is that when f prime of x changes from a positive value to a negative value, there is a local maximum at f of x. If f prime of x changes from a negative value to a positive value, there is a local minimum at f of x. So you're looking at the green graph again, and you can tell that at x equals -1, it goes from a positive value to a negative value. Therefore, there's a local maximum at x equals -1 of f of x. And you can also see, still at the same green graph, that at x equals 1, it goes from a negative value to a positive value. Therefore, f of x has a local minimum at x equals 1. The third thing you may need to know is if f prime of x is decreasing, f of x is concave down on the interval, on the interval it was decreasing on. And if f prime of x is increasing on a certain interval, f of x is concave up on the same interval. So you're looking at the green graph one more time, and you can see that when x is less than 0, it is decreasing. And when x is greater than 0, it is increasing. Therefore, the graph of f of x is concave down when x is less than 0, and it is concave up when x is greater than 0. Now I'm going to talk to you guys about the relationship between the original function and the second derivative. So it says that if the second derivative of x is greater than 0 for Rx in a certain interval, the graph of x is concave up on the same interval, and vice versa. When the second derivative of x is less than 0 for Rx in a certain interval, the graph of f of x is concave down on the same interval. This time you're looking at the pink graph, and you can tell that when x is greater than 0, it is above the x-axis, and when x is less than 0, it is below the x-axis. Therefore, the graph of f of x is concave up when x is greater than 0, and it is concave down when x is less than 0. And the final thing you may need to know is that the x-intercepts of the second derivative are the inflection points of f of x. So you're looking at the pink graph one more time, and you can see that the x-intercept is at x equals 0, and therefore the graph of f of x has an inflection point at x equals 0. And that's all you may need to know about curve sketching. So yeah.